Now let's do our update with a multiple column subquery, updating multiple columns in the show table. You see we have 2 rows updated. First of all, we're going to want to look at this name column. So let's restrict the width of it so we can see what's going on. We said we had show ID 17 and 27, so we'll select show ID, show date, and name from show. And we could restrict it by specifying that the show ID is in 17 and 27, so we find the exact rows that we know we've updated. This verifies that we've set the show date to something which here is null. We set it to the system date, and we set no date set. My current system date is the 5th of February 2003, which is what my show date has been set to. Now let's do an update with a subquery. In this particular update statement, I'm going to set the price in the ticket table for each row to a single row subquery produced by a join between the show, seating map, and venue tables. I'm also going to apply a subquery in the where clause restricting the venue to compact center. So I'm only going to update ticket rows where those ticket rows represent compact center. So I'm only going to update the tickets for compact center, and I'm going to update the prices based on seating map values and any changes I may have done to the price multiplier fields and the standard price fields. As you remember, previously I actually did change values in these fields. So this is how we would actually pass those changes from the seating map, which, as you can remember, is a map of prices, not actual ticket prices. The price multipliers are used to alter prices for different shows based on who the performing artists are. So let's go and run this query. It seems we have an error. Well, this is useful because using the asterisk, SQL Plus has shown us exactly where the error is. It's shown us that the error has been encountered at this field called name. In this subquery statement, now this should be fairly obvious to sort out, this subquery is here. It's saying where venue ID is equal to select name. Well, it's detected that venue ID and name are actually different data types, because what is actually happening here is the where clause is verifying venue ID against name. Venue ID is, of course, a number field or integer, and name is a character field. There is no implicit type conversion there. We wouldn't want one either, because that is actually incorrect. So what we'll do is we'll go back and change this SQL statement and put the right field name in, as we should have done in the first place. However, that was useful because that error actually showed us where the mistake was made. Just remember that the asterisk will generally try to point to the error. Sometimes errors in SQL statements can actually be caused by things further up in the lines of the SQL code, so they can be difficult to find. This is useful to display though, because it has actually shown us exactly where the error is. Let's run it again, and here we have the update statement executed. 245,600 rows have been updated. Let's verify the correctness of that update statement by once again counting the tickets in the ticket table based on the venue. So we updated 245,600 rows, and here we have the tickets, exactly the same number. The update statement worked correctly. Let's do one more thing with the update statement. I have a name field on the show table which is currently empty. So let's select name from show. They're all blank. What I'm going to do is I'm going to give it a default value. Let's just select that name field again from show, and we'll see that it's still blank. The default setting allows a setting to default when DML statements are executed against this table. So merely setting a default value does not set a column value. So let's go and update the name field in the show table with the default setting. This will allow us to set all the column values to that default value. Once again, let's select the name field from the show table. As you can see, the name field has been set to the default value.